Yeah, so good morning, CraftConf. Welcome to our talk about complex event flows in distributed systems. You already introduced ourselves, so my name is Bernd Rücker. I'm co-founder of Camunda. We're actually developing an open source workflow automation platform. We're based in Berlin, in Germany. I wrote that lovely BPMN book that's also available in English. We're talking about that probably a bit later on. And as I think we will run short in time at the end of this talk, there's my email address, there's my Twitter handle. Don't hesitate to ask any questions, send me an email, tweet me. I'm here the whole day, so ask me anything you want to.
Yeah, hello and welcome from my side too. My name is Martin Schimak. I'm independent software developer. I'm living in Vienna, in Austria. I'm quite into that topic of domain-driven design, and I've also recently gave some talks at different domain-driven design-oriented conferences 2 weeks ago at the DDD Exchange in London. And I'm currently doing work in the telecommunications industry, and I'm also using Bernd's technology on a daily basis there.
Okay. What we basically see out there at all the customers is that we are currently moving towards very distributed systems. So the most systems you build are no longer monolith, are no longer one Java application, one whatever it is, JavaScript or whatever, but you start to build very distributed systems which are really connected, and that poses a lot of new problems we see out there. And what we will want to do today is we want to look at that from the perspective of one example, and we use an order fulfillment example, and that's motivated at least by what Zalando does. You probably know Zalando. They're active worldwide, not in Hungary, unfortunately. Probably they started, but as far as I know, they don't. And they, in one of the last quarters, they did more than 22 million of orders per quarter, so that's quite an amount. And they, at a meetup last year in Berlin, they told about their order fulfillment process, and by coincidence, that runs on our platform. So that's a good example to look at. And if you want to build such a system, it might be very interesting to also look at, for example, at domain-driven design. Who knows what domain-driven design is about? Who uses DDD in practice? Okay, that's kind of the normal situation, okay. And yeah, if we want to learn something from DDD, that would be awesome. Martin, can you enlighten us a bit?
Well, I will kind of try my best. I want to particularly focus on how would we actually typically get started when we look at such a thing like order fulfillment. So we have a quite large end-to-end process going on here. So we'd like to have that big picture first. And there's a quite popular workshop format in the domain-driven design community. It's called event storming. And we would typically use lots of colorful sticky notes on a large wall, unlimited modeling space, and try to model all the details. First get started with some first events. So I show you a very simple example of that order fulfillment here. We, of course, want to make a customer happy, so some customer wants to have those goods shipped, and we see some events on our way to that success. So when the customer has placed the order, we would, of course, like to get hold of our money. As soon as the payment is received, we would need to fetch the goods from the inventory, and when that is done, we can ship them, and when the goods are shipped, we are happy, and the customer is hopefully happy too. So that would be a very simple example of what we are trying to do here. Now, when we look into what those events actually are, then we can say, well, on one hand, they are quite easy to grasp from a business perspective, but then from a technical perspective, they are also something interesting. They tell us something about what already happened. Those are facts. The moment we publish such a thing like a payment received event here, that already happened. So we would also use typically that past tense to express that payment is received, and we can look into the past by listening to that event. Now, events help us a lot when it comes to decoupling services. Imagine, for example, we would have two services here, not just that payment service, but also an order service. And that order service would like to present some order summary to a user. the customer probably. But we would also like to show a little flag there. Is the payment already received or not? But instead of asking the payment service now at the moment at which we actually render that order summary, we just leverage that event. So the moment the payment service has done that, it publishes an event, and the order service is then able to consume that event and project it kind of onto its internal data structure. We call that a read model. And you can say we can actually decouple non-functional requirements we have for those services here. Now, events also help us with cost-cutting concerns. Imagine customers want to be informed about a lot of things, like is the payment already received or not? Maybe I want to send them a notification that we just started to fetch the goods from the inventory or that we start to deliver it. Customers maybe want to configure all that, so we could factor out that notification concern into a notification service. That notification service would now source events from different systems and services, and all those other services which publish those events would not need to know about that notification concern at all. So again, strong in decoupling. There is a caveat, however, when we now start to think, and we see that actually quite often, let's just use events in between services. You know, those pure event-driven architectures. When we look at such things like order fulfillment here, longer chains of events used actually to trigger follow-up services, payment service would listen to order placed and start to retrieve the payment. As soon as this is done, in our simple example, it would again publish an event. The payment is received, so our next service could listen to that. So we get that event chain here. Now, what is typically the coupling issue that we see here arising? I want to illustrate that with a simple change request. I would like to actually get hold of our goods first, fetch that from the inventory, and when I've secured that, then I would like to start to charge our customer. So I would remove those 4 sticky notes here and put them back on the wall. Those 4 sticky notes I just touched, but actually now thinking about it, we have to change 3 services. Because all those 3 services would now listen to different events than before. When you think about it, inventory, payment, and even the shipment service is now listening to different events. And we would have to synchronize those deployments. So this is typically something that you want to avoid when you reach out for that service autonomy, a typical goal when you're doing microservices in particular. Now, what is going on here? In order to understand it a bit better, you have to see that when we listen to an event, the event as such is just a fact. So it's not directly triggering anything. We always have to come up, when we listen to that event, to come up with some policy, some business rule in order to decide now, okay, do we want to follow up with some action or not, or maybe just under certain circumstances? So there are business rules involved. As soon as we know that or start to see that, there's a start fetching policy involved here. And in a pure event choreography, that start fetching policy, of course, would be hosted, would be owned by that inventory service. It is consuming the pure event, but now also need to evaluate that business rule that might be behind here. And it's very probably not an easy thing like whenever a payment is received, we would start to fetch the goods. But it is more like maybe we want to speed up things and parallelize things for prime customers. So payment and inventory would actually work in parallel. Maybe we want to wait for that payment received event just for new customers we cannot yet trust, and on and on and on. What about invoiced customers? So when we ask ourselves who should actually own that policy here and look at the other side of things, then we can also see, should the payment service now care about parallelization and such things in between those two services? Probably not. It's not a payment concern. Payment service should care about I'm getting hold of that money. So what can we do? Third option is just that we kind of introduce a mediator service here. So we would have an order service which would now host that start fetching policy and would be able to mediate in between those concerns and would be yeah, a kind of orchestrating service here. We will come back to that later. When we look at that picture now, with that order service, we can have a quite clear picture with regards to that, yeah, well, core business of that company. This is very transparent now. And we can also double check with regards to our coupling issue I just discussed. When we, again, switch the two services here, inventory fetching comes first, then yes, we have to change sticky notes, but at the same time, we actually didn't change anything inside those two services because those services are now not listening to events, but reacting to commands like fetch goods, request payment, and that command is issued by that order service. So with regards to that coupling, we would of course have to change some things in the order service, but it's just one service that we need to touch now here. And that is actually what we kind of wanted.
Switched positions, actually, yeah. So let's assume we have these 4 services we talked about. And now one of the interesting problems is that how can these services collaborate to get something done? And these are the, I mean, you might want to do microservices, then you have a lot of services. You might even do serverless, then you have a lot of functions. So these are problems we get a lot currently, smaller units of work, smaller components to collaborate to get something done. And if you look at that, I have an own QCon talk given on that, and I wrote an article on InfoWorld about the 3 common pitfalls of microservice integration. Obviously, my opinionated view on that world, but something we see a lot in customer projects. And I want to highlight one which is very important for the point we want to make today. And I want to tell a short story about that, which is, I think, very easy to get the whole point. Who has used an airplane before? Awesome. You're familiar with the process, right? You book a ticket. One day, typically before the flight takes off, you get an email invitation to check in. So you click on the link, you go to the check-in page, you select probably the seat where you want to seat, you confirm that you don't take dangerous goods, and then you hit a button which says check me in, and the next page says, okay, send me my boarding pass, right? You know the button, send me the boarding pass. When I did that last year, when I flew to London, it gave me an error message. It's in German, but it's very easy to get. It basically said, okay, there was an error sending you your boarding pass. Okay, that was the error message I got. Which is quite a pity because I wanted to have my boarding pass, obviously. What would you normally do? Yeah, retry, right. We're programmers trying to turn it off and on again. So I obviously have to retry it. But the first thing which is really interesting to look at is actually who is doing the retry here. So I imagine that the airline works something like this. So this is me, then I use a web component. The web component uses an upstream check-in service, for example. The check-in service cannot do everything on its own. It uses other upstream services, for example, a barcode generator, or PDF generator, or an output management. Actually, output management seems to be a real problem in most of the companies I know, so this is very realistic that this probably failed. So that's my assumption what happened. It probably failed there. But what they do, they make this to my problem. Now I have to do the retry. And in this case, I retried it. Immediately, it didn't work. I retried it 1 minute later. It didn't work. What would you do? I retried a couple of hours later. It did work. Very natural for me. My wife would go crazy for that. Why does it work 4 hours later? For a computer scientist, it's logic. For other people, normally not. And it's a pretty bad design. It's now my problem to do that retry. And I have to be stateful there because if I have to wait for 4 hours, at least in my mind, I forget about these things. So I made me a calendar entry to remind me to send my boarding pass. That's pretty bad. I mean, no, the best part of that story actually was when my flight back, it was really the flight back from the same appointment, was with EasyJet. They said, "We are sorry, we're having some technical difficulties." At that moment, I was a little bit happy about the error message because I started to collect them. But they, and that's awesome, they give me the work instruction. Please log on again, retry. If that doesn't work, please try again in 5 minutes. Okay, increase the interval, makes sense. And the best thing is that we do actively monitor our site, we'll be working to resolve the issue. There's no need to call, it's your problem. Do it yourself, we don't want to do that for you. And that's bad design. And I mean, in this case, it's customer facing, but it's the same situation if you're having internal services that are clients. The same problem, they don't want to do your work. It's your work, you should do it yourself. And in this case, I mean, they sent me the boarding pass asynchronously, via email, via message. They could do that whenever it's possible. They don't have to do it right away, they can do it whenever it's possible. So it would be much better to say something like this, okay, we have a technical problem, whoa, that's bad, but it's our bad. We take care, we send it to you whenever you're ready. Don't worry, okay? That would be cool. And that would mean that they resolve the problem where it belongs or where it should be resolved. In this case, for example, in the check-in service, it can do the retry itself. And then it's very local as well. So you don't have to handle that exception or that problem, that failure, the whole hierarchy upstream to the user. You handle it as local as possible. That eases the architecture a lot, so that makes a lot of sense. The problem, what I see why a lot of projects are not going down that route is that that stateful retry. If I promise the user to send his boarding pass whenever I'm ready, I should do actually. And even if that takes 4 hours or 8 hours or 2 days or whatever it takes, I should do it. And that must be stateful because if I restart the system, it should still be done. And that's a thing, and then we have to handle state. We have 2018, handling state is probably not such a deal. Probably it starts to be more complicated again with serverless, but there are ways to handle state. I mean, the very naive approach would be to what I always call a persistent thing. It could be an entity, database table, it could be a document, it could be a persistent actor. I actually don't care, but it's kind of a persistent technology you can leverage yourself. And normally the project senses that this is probably not the best way to do because then you start to have additional requirements. Okay, I have to do that retry, so I have to have some kind of scheduling mechanism, doing the retry, doing it a couple of hours later, probably persist that, and so on and so on and so on. And that's typically true. If you start just using a small database table for that, you start coding a lot of stuff around. You start having a lot of accidental complexity. So that's not a good idea to do, actually. But it's not an alternative to just throw the arrow to the client and don't care about it. There are actually quite good tools out there which I would classify as state machines, or normally they're called workflow engines currently. The problem with workflow engines is most of the time they have a bad reputation. So if I say workflow engine, and in the intro you got that I'm a workflow automation guy, I do this really my whole professional life. I'm absolutely crazy about workflow engine. I love this technology. And normally, but if the people hear that, they say something like, oh, workflow, that's a BPM thing, and these are these like big vendors and unhandy machines, proprietary, I cannot write tests. I have to click through a lot of wizards in order to get something done, and that's what I call death by properties panel. And a lot of these kind of things, and I mean, I run things at scale. These machines don't scale at all, so I cannot use them. And I understand why these conceptions are there, because they're like 5 or 10 years ago, a lot of vendors sold their machines like this, but they are not true anymore, and that's important to keep in mind. So if we look at the workflow engine market as of 2018, and there's a lot of things going on. So for example, all the cloud vendors are investing in that. So one example is AWS, Amazon. They're doing step functions, but the other cloud vendors are doing something similar, especially to get ordering and persistent state into calling a couple of functions in a sequence, for example. So that's very relevant for them, actually. They're investing in that. If you look at the Silicon Valley stacks, like, for example, Netflix is doing something with the Conductor project, or Uber did something with Cadence. They're very proprietary to the world these Silicon Valley companies live in. So, for example, in Conductor, you have to use DynamoDB, or Uber is only Go and Cassandra, so that limits the use cases. But it shows that they also have to solve that problem, and they use a workflow engine for that. And there are quite still a lot of open source projects out there, which you can also leverage, which are very, very, very lightweight and also easily available. So these are just a bunch of them. There are even more nowadays. These are the most common ones. Also at scale, I will talk about that in a minute. So if you have really like a high scalability environment, it's also possible. So it's not that this is slow technology or not scalable technology. I will talk about that later. For today's demo, because I'm a guy, I always want to show code. In the presentation, I use, by coincidence, the framework from the company I co-founded, so bear with me. But the other ones are kind of comparable, okay? So very lightweight, in this case, Java frameworks. And if you have this kind of workflow engine, what you can do is you can leverage that within your service. So if you have the check-in service from earlier on, you could have like a very easy workflow definition. We do that in a minute live, so you can get a better idea what that means. And then you can do what I call stateful retrying, the one I talked about earlier. So I could define that this creating the barcode should be retried for hours if necessary. And that's stateful. So if I restart the system, it's somewhere in a database, in a storage, it's there, it's safe. And then you can even have like additional stuff, like if that takes too long, like 4 hours before the flight, I probably want to stop retrying because it doesn't work, and I want to inform my customer that he should go to the counter, for example, whatever it is, what I want to do there. And it's very easy to have this notion of timeouts, and these kind of things. And you have a lot of problems in distributed systems which basically match to these things. You need retries if you're doing REST calls. If you're doing asynchronous messaging, you probably have timeouts for responses and these kind of things. So that's actually a very, very important thing. I want to dive into a bit of code in order to make it very, very concrete, very tangible. I use Java here. Who's using Java? Okay, that's actually most of you. Who's using .NET? JavaScript? What did I miss? PHP? Go? Oh yeah, okay, awesome. I use Java here, but that's the majority, and I use Spring Boot. And I go back to the payment example Martin introduced. So I have a payment service, and I have an upstream credit card service. I'm using Spring Boot. Who's using Spring Boot? Just to finish that small poll. Okay, not that much actually. Okay. If you have used Spring Boot before and you write a REST service, it probably looked like this. So I have a REST controller, my payment service. I do a couple of Spring things like autowire. Can you read that actually? No, yeah, that's what I thought. Font, you should read the code, otherwise it's not fun. So let's do 22. 22 could be good. Can you read the code? Yes? Okay, awesome. Last row say yes, that's good. We can also get rid of a couple of these guys. So it normally looks like that. You have a REST controller, you have a mapping, so if I call API payment v1 with a put, this method is called, then I do a couple of things. That's just mock code, so don't care about that. But the thing I want to do is I want to charge the credit card to do the payment. And if I look into that, the typical Spring way of doing it, if you use another framework, it might be a bit different, but you create a request, and then you have a REST template that's from Spring. And then you do a post, for example, to send that request to a certain URL. And then you get a response back, and then you're done. Okay, easy. Right, who has done something like that? Oh, not that much? Oh, no, okay. Okay, you were slow. You were, this is boring, boring, boring. I do something else. Okay, understood. It gets more interesting in a second. So this is basically the basics. What I actually did to make it at least a bit more realistic, I added, the only thing I did here in a V2, I added hystrix. I can show you that in a minute, but that's not the focus of today's talk. So I added hystrix in order to have a circuit breaker there. What happens now? So I have my upstream service. Where is it? There. This is my upstream Stripe service. It's operating normal. That's pretty good. And this is my payment service. I have a REST API. I can do a payment request to V1, and it gets completed. Not that awesome, right? Kind of boring. Well, not that boring, actually, but kind of boring. I can make it slow. Slow typically means it blocks the request. That's actually a bad idea. That's why we use Hystrix as a circuit breaker to avoid blocking the request, and then we get basically a failure from Hystrix. So this is what you typically call fail fast. Now I could have the message presented to the user, hey, you cannot send your boarding pass. So this is not what we want. So what I do in the next step, and that gets more interesting in the V3, and by the way, the code is on GitHub. We have the link in the slides. You can look through all the code later on. What I can use now is the workflow engine. In this case, for Camunda, the class is a process engine. I can auto-wire that with Spring Boot. We have a Spring Boot starter. The same thing for a couple of the other engines as well. And then I define the workflow definition. You saw the graphical modeler earlier on, so you could do it with a graphical modeler. But very often in technical environments, normally for developers, I show it in code first, because you can also use the Java DSL, or you could use YAML. So there are different ways of doing that. So as a lot of people are normally scared by graphical models, oh, there's magic behind. No, there's no magic. This is it. So I define a flow. It starts somewhere, then the only thing I really do is a service task to call the upstream Stripe service. I attach code. This is a Spring expression in this case, so the Stripe adapter is here, Spring component, and when it's executed, it's exactly the code I had earlier on. So that hasn't changed. I just now move it into that, what we call a delegate, which is then called from the workflow engine. And then I have that state machine, and then I can attach additional requirements like do a failed job retry. So that's the retry. And in this case, I say retry it 3 times with a delay of 1 minute. I have multiple options to do the retry. But the important thing is now I have the state machine, and it does the retry. And it's safe. It's persistent. And then I'm done. That was my definition. I deploy it to the engine. The engine can keep track of versions, so even if I change that, deploy it later on in a different version, I have a different version. So these are normally requirements you get as soon as you start going to these longer running things. And then the only thing I do here when I charge the credit card is instead of directly charging it, I start a workflow, which then charges it and do the retry if necessary. And now the whole game changes. So my service is still slow. Where is it? Where is it? Where is it? My Postman here. Hang on, I want to have the slow service here. There it is, slow service. And now I go to V3. I hit it. And what happens is, in this case, I get a HTTP 202 accepted. So I made this asynchronous. We talk about that in a second. And get back a status, OK, pending. So I got the request, and I take care. That's what I say here. If you look at the thing in the background, there's an engine, a workflow engine running. They typically have user interfaces like, for example, this one in our case. And there I can look at V3, and I can see, OK, there's 1 running instance, because I couldn't complete the Stripe service. It's still slow, right? And if I change that to behave normal, after a while, the retries will heal itself, and that workflow instance will continue. Now, you probably, normally, now we start the discussion, OK, but now it's asynchronous. The guy wants to have a confirmation that the boarding pass is sent immediately. OK, then you can do that. You can. I don't want to dive into the code because of the time, but it's very easy to mask that you get a synchronous response, what you can see here, 200 OK, very fast, if the workflow engine can do it directly. And if I change it to slow again, then we're switching to a 202 accepted. So just because you use that kind of technology doesn't mean you're asynchronous or you're out of luck for these kind of things. Okay? And what my goal was that you can see that it's very easy to do. That's little code you need, and you can run it embedded in your service if you like. Okay, so it's nothing a lot of people think of workflow engine as kind of central component. No, it doesn't have to be. It can run as part of the service. Oh yeah, we have the life hack. And then you have that state machine. That's what I did. I had the charged credit card in the payment service. And that's actually awesome. It's persistent. If you look at distributed systems, let's assume we do the following. We say, OK, we now do that charge, the credit card. We do the retries. But after a couple of retries, we skip it. We say, OK, no, that's done. We just raise a payment, failed. That would probably make sense, right? To say, OK, no, we give up. There's one important thing about distributed systems. And I like this picture about distributed systems because the small hut, the house here, that's one application, one Java application or JavaScript or Go, whatever it is. There you probably have transaction management. It's cozy in there. It's great. But you open the door and you have that rough ocean where the network, and that flips bits around, and that will make your life hard. And one problem, just as an example, is this one. So if you have, for example, doing a REST call, and you get a network error, you have no idea if that was on the way to the service, if it was basically the service blew up and couldn't give a response, or if it processed the request and the response got lost. And that same thing with messaging. The response can get lost. So that's a pretty bad thing. And you cannot differentiate that. You have no idea. You just can't. So when you have that situation, when you raise the payment failed, you probably have done the payment. It's probably not that funny for your customer if you've done the payment and don't deliver the stuff. So you have to think about that. So you have to, for example, there are different strategies, but you have to do a refund, you have to check if you credited it, or there are a couple of possibilities what you can do there. But you have to take care of that, and you have to do it reliable. And again, even the refund might be a REST call, might not be available. You probably have to do a retry, stateful. So you have to take care about these requirements. So for me, that's a very important thing, and that's what I see missing in a lot of the architectures at the customers I currently see. This brings us to another topic, which is awesomely interesting, but we don't have time to dive into the details. I only want to scratch the surface because it's very important. Consistency. We're talking about consistency here a bit. And if we have the distributed systems, one thing what you don't have is distributed transactions. Sometimes people say, OK, no, but there's these XA or two-phase commit or three-phase commit. There are distributed transactions out there. No. And currently, there's not. You should assume you don't have distributed transactions. There's an awesome paper on that written by Bernd Rücker, at that time at Amazon. Now he's at Salesforce. And it's still very valid. So why, if you want to read about it, why distributed transactions just don't scale, that's the awesome paper. For the moment, I would just assume it's true. We don't have distributed transactions, but we have the requirement. We have like a couple of activities in a row, like doing the payment or whatever, and if that doesn't work, we have to roll back somehow. And that's also, for example, what a workflow engine can do, what BPMN can do, that's a compensation. So you could say, like, if the charging the credit card fails, I can basically issue a compensation, and that means all the activity completed successfully in the past will have this compensation activity configured, will compensate. And again, reliable with persistence. That's very important because then you have like local transactions in the services you call, and the overall transaction, it's not a real technical transaction, it's basically this compensation mechanism, very often also known as saga pattern. We don't dive into the example right now. If you want to play around with it, you can do. So there's a V6 available. I have to do one thing, which I don't want to explain at the moment. So if I have a V6, I can start a couple of these things. Try that at home. Yeah, you're eager to get back to your slot. Yeah, I know. And then, for example, you can see also like how the instances run. And I typically have random failing instances where you can see these, also the failure. Good. So we have these long-running services now, and that's actually a very important basic because it resolves also a couple of more problems. There might be one thing you might be aware of if you're using microservices. There's a good book from Sam Newman, and within that book, he wrote one sentence which basically says if you're using orchestration, and also workflow engines or orchestration. Martin talked about orchestration, the orchestration order service. If you're using orchestration, there's the risk that that you end up with a few smart God services telling anemic CRUD services what to do. So basically, my visualization of that is like this. So you have a huge order service and a small payment service, and that doesn't have to be the case.
Okay, when we look at that problem, and Sam Newman also says those services, those quite central services tend to suck business logic into them, kind of. I just would like to point out that in my mind, it's really not that much about the fact that we have some coordinating services here. But it's really more about that other part of what he actually states here, tell anemic CRUD services what to do. So the really important part here is that we actually focus, when we look at that payment service here, that we focus on that API, that we ask ourselves, what is actually that business capability our client, in that case it would be the order service, is interested in? What do we want to have when we use a payment service? Or let's put it the other way around. When the payment service starts to retrieve the money and then finds out, okay, the credit card expired, that doesn't work, it failed, and then kind of stops and says, I don't want to take care of that problem, here's a problem, deal with it, to its client, what happens then? When we expose that problem, of course, somebody has to deal with that requirement. We just said that we want to retry eventually with new credit card details. So it's now definitely the order service who has to mitigate that problem. So it's actually not sucking in logic, in my mind, but it has a lot to do with that API design. When we think about services a little bit more like self-contained, small state machines, kind of, then we also get to a better API design. Looking at the requirements for a payment service by means of event storming, we will, because we have that timeline, we have that bigger picture, we will easily find out that we are actually looking for that end result. Payment received is what our client is interested in. And the payment service itself actually is something like a long-running service. It needs to take care of several steps in order to come up with a meaningful, ultimate event like payment received or eventually payment cancelled, if it just doesn't work out, because even after 2 weeks, the customer didn't get back to us and didn't provide any new credit card details. So when we design services more around those long-running business capabilities, then we try to create value for a client, the value the client is really interested in. And we also assume responsibility for that value. We always ask ourselves, what are all the things that we should take care of? Because it's in our responsibility and not a client issue to do that. And obviously, we would need to go asynchronous, typically, in order to enable that composite kind of execution we are looking for here, because we cannot deal with that request payment command in just one single atomic step. So looking at payment from that perspective, you can, of course, now ask yourself how to implement. And I just want to point out, Bernd is always very enthusiastic, of course, about technology. Fair enough. I just want to point out there are, of course, many ways to do that. Look into actor frameworks. Consider Akka. Or something I want to point out here, when you Google for Saga management, then you will also find helpful frameworks which are actually messaging oriented and have eventually explicit means to deal with stuff like long-running processes. So I can annotate a class as a Saga here when leveraging that Axon framework, and then I can I get some support to correlate events to that case of our payment retrieval here. I have the possibility, because it's a stateful instance, to save some process state in order to have that readily available when I'm using when I'm evaluating some further event coming along later on. And then I just basically need to implement my business policy. What do I actually want to do with that event? Maybe I just decide to wait longer. Maybe I decide to create and issue a new command. And of course, something like Camunda, process engine execution, has its merits too. It gives you a lot of visibility. And it can also work in a quite message-driven way, reactive way, to say so. We could basically directly map our event storming result to that BPMN model here. Yeah? We are receiving an event, we are evaluating some policy depending on our account balance. We want to raise or issue a new command like charge credit card, or we would find out we have some positive balance, so we would actually like to withdraw that amount from the account first. And then we would passively wait until another event arrives, like credit card happily charged, so we can already move on our happy path here. So mapping all that onto such a graphical model is actually kind of a no-brainer once you have that. A last thing I want to point out from a domain-driven design perspective that is really important for me. Domain-driven design encourages you to respect your boundaries. Bounded context is about model and language boundaries, but also service boundaries. Think in the direction of capabilities, and that payment service should really take care of what a client like order service is interested in. So it might be enough to expose that request payment command to an order service in order to say, okay, could happen very fast, but could also take up to 2 weeks until we see that payment received event here, or eventually a payment cancelled. But that's actually all our API here. And in that example, both services are now implemented with workflow. Many people are afraid of workflow because they associate it with things that need to happen all over the place. But this is actually not the case. This is, when you do it right, technology that enables a service inside of the service, the long-running capability. And it's now a local technology decision. Maybe I just don't want to do it with Camunda in that case, but there are maybe some services in my landscape where I think, yes, actually it makes a lot of sense to do it like that. If you are like me, then you like to do a lot of things in code. I recently wrote a little integration between that Axon and Camunda stuff. If you're interested in that, head over to that GitHub repository and find that.
Yeah, there's other code available as well. The same example we have also on that URL. There's an example with the order fulfillment. I have it in Java and Spring Boot, or in C#, if you like, and I use REST or Kafka, so it's a REST and a messaging-based system, and Camunda or CBS and engine. So if you're looking into code, there's a way where you find it. If you're looking into high scalability, if you say, okay, this workflow engine, relational database of Camunda, oh, that's pretty bad, that's probably also interesting to look into CB. I'm currently writing an article on that, how we do a really horizontally scalable workflow engine which can process the same amount of events like Kafka in the same order of magnitude, and is really scalable based on event sourcing. If you're interested in that, talk to me. Thank you very much for listening, for being here. These are all the links. You find everything online. If you have questions, I think we have time for 1 or 2 questions. Yes. Thank you very much.
Thank you so much for the amazing talk. Yeah, I think we have time for a couple of questions. So the first one that we received on Slido is, do you have one central event system for all services, or event system per domain? Who is responsible for maintenance of the event system?
It goes, I think, into your direction.
Well, depends on, typically, if we are speaking now about a microservices architecture, I would say go for local technology decisions. You probably know that smart endpoints dump pipe, Martin Fowler in his original microservices article. So you typically would not like to have any business logic in that central infrastructure component. And yeah, the way I would apply it is definitely the local decision.
Thank you. Oh my God, the questions are moving like crazy. So what happens if the request is still not successful after the defined number of retries?
Yeah. So I think Martin had it pretty good on the slide. So if it's not successful after some time, I mean, it might be that you raised like a canceled event or a failure event, like an end result. That's very valid that it can do, and then you have to react on that. And depending, I mean, if you do this transaction stuff, the saga, the compensation stuff, it might not always be easy to decide what you do in case of failure, but at least you really look into the problem and do a very cautious decision on that. So.
All right. So, okay, let's go with one more question. People are really interested in the audience why you're still using Eclipse.
Yeah, I get that question quite regularly. I think it's my own laziness. I grew up with Eclipse, and so I'm pretty fast with it, and I know all the glitches, so I stick with it at the moment. So that's the only reason.
All right, let's give another applause for our speakers.
Thank you.
Thank you so much, Martin and Bernd.